Hello everyone, I am Professor Bankar DB, Department of Chemistry, RBNB College, Srirampur. In previous lecture, we have studied the synthesis of multistratin molecule using the concept of Chiron approach. So in this lecture, we will see the synthesis of next molecule, that is pentenomycin molecule using the concept of Chiron approach. So in this lecture we will see the synthesis of pentenomycin molecule. Here the structure of pentenomycin is given. Pentenomycin molecule consists of 5-membered ring, cyclic 5-membered ring. This ring is attached with different functional group. So this pentenomycin molecule consists of double bond, 1 carbonyl group and 3 hydroxyl group. So this is structure of pentenomycin molecule. So we will see the detailed synthesis of pentenomycin molecule using the concept of Chiron approach. So synthesis of pentenomycin begin with carbohydrate, that is D-glucose molecule. So this is structure of D-glucose molecule. So in first step, D-glucose molecule is allowed to react with acetone in presence of H+ and under heating condition. So there is protection of diol takes place in presence of acetone molecule under acidic condition. In next step, this compound is allowed to react with ruthenium tetraoxide in presence. So there is oxidation reaction takes place. This OH group undergo oxidation into corresponding carbonyl group. So we have this new structure. In next step, this ketonic compound is reacted with mild base and CH2NO2, that is diazomethane. Here we use CH3, that is diazomethane. So this mild base can abstract the proton from CH3. There is formation of CH2 minus, that CH2 minus attack at this carbonyl carbon, and there is formation of bond between this carbon and this CH3. Look at this step. Mild base react with diazomethane. There is formation of carbanion. This carbanion attack at this carbonyl carbon, and there is formation of this new intermediate. This carbon is converted into corresponding OH, and this CH3NO2 form bond with this carbon. Look at next step. This nitro compound is then reacted with alkaline KMnO4, that CH2NO2 group undergo oxidation. There is formation of carboxylic acid group. In next step, we use sodium borohydride. That sodium borohydride reduces acid into aldehyde, and that aldehyde into further alcohol. So under this two step, we get new compound. Look at next step. This alcohol compound is allowed to react with benzyl bromide, that is BN-Br, in presence of sodium hydride and DMF solvent. So this sodium hydride take this proton, there is formation of O-, and this O- attack at this benzyl bromide compound. So there is conversion of O into corresponding OBN. So in this step, we protect that OH in the form of OBN. So this OH is converted into corresponding OBN. So this is protecting step. Here this ketal undergo deprotection under acidic condition. So this ketal is allowed to react with acid, that is H+. Here we use HCl water condition. So under acidic condition, this ketal selectively undergo cleavage and there is formation of a diol. In next step, this diol is allowed to react with sodium periodate. So under sodium periodate reaction condition, this bond undergo cleavage. There is formation of aldehyde at this particular position. So this aldehyde then react with sodium borohydride. There is formation of OH. In next step, this OH is allowed to react with tosyl chloride in presence of pyridine. This OH is more reactive as compared to this OH. Therefore, selectively this CH2OH group undergo reaction with tosyl chloride in presence of pyridine, and there is formation of OTS group. As compared to OH, OTS group is more good living group. Look at next step. This tosylate intermediate is then react with methanol in presence of HCl. So under such type of reaction condition, this ketal undergo cleavage. There is formation of OH and there is also formation of OMe at this particular carbon. Here, this intermediate is then react with a dimethyl dimethoxy methane molecule. In this particular step, this diol undergo protection. So in presence of this reagent, this diol undergo protection and we have this type of new intermediate, that is ketal intermediate. In next step, this tosylate intermediate is allowed to react with sterically hindered potassium tertiary butoxide base. So this potassium tertiary butoxide base abstract the proton present at this carbon. There is formation of carbanion, and this carbanion undergo this type of changes. There is loss of OTS group, and here there is formation of C double bond, that is carbon double bond CH2 group. Then this alkene intermediate undergo reaction with H3O plus acid hydrolysis reaction. In this reaction condition, this bond undergo cleavage, and there is formation of ketone and aldehyde. Look at next step. This ketone and aldehyde undergo intramolecular aldol condensation reaction. This ketone and aldehyde undergo intramolecular aldol condensation reaction in presence of alumina and this much temperature. Here we use alumina instead of acidic or basic hydrolysis condition due to the presence of this type of acetal group. So this ketone and aldehyde undergo intramolecular aldol condensation reaction, and there is formation of alpha beta unsaturated ketone compound. So this is simple intramolecular aldol condensation reaction. Look at next two conjugative steps. Under acidic reaction condition, this ketonic compound undergo changes into this type of new compound. There is formation of OAC group. In last step, this acetate group undergo decomposition in lipase enzyme. So this lipase enzyme convert OAC group into OH group. So this is structure of pentenomycin molecule. So in this way we synthesize pentenomycin molecule by starting with D-glucose molecule. So in this lecture I will stop here. In next lecture we will see the next molecule, that is synthesis of new molecule using the concept of Chiron approach. I will stop here. Thank you.